Hello, in this part I will show you a bit more advanced things about the load bearing tower placing tool. So this first thing will be the error messaging. So this tower, actually I'm gonna just delete it and create a new one, and I'll show you how the error messaging works. So one thing that I know we're gonna have error is if we use this configuration, which means we are forcing the system to use 90 centimeters at the bottom and 90 centimeters at the top, which means that you physically have 1.8 meters guaranteed, and the system tries to fit whatever it can in between using all possible configurations. And also from the top it subtracts the height of the superstructure, which in our case is 318 millimeters. So once we create this and place it here, 1 second to see if we are in the proper host is helper family. So yes, we are in the right place, but the other way to see that is just go from the site and see. And the reason it's going to trigger an error is because it's only 2.9 meters. So when you subtract 30 centimeters from the top for the superstructure, you're left with 2.6 meters, and then after you remove 1.8 meters out of this 2.6, you are left with 0.8 meters, and the lowest possible frame we have is 0.9, so it will not be able to find a suitable configuration. So let's see how it will work, and then we'll see the error. So nothing happened. That doesn't mean that the system didn't work. It means that it couldn't generate anything. So you select it and you hover to the properties, you can see that there is a parameter called error message where it says no suitable frame configuration was found. Please check your frame configuration options. And the frame configuration options is written here, and this is the one that we selected. You can edit it from here manually, but I would not recommend that. So the best the best way to resolve this issue is just to go to another configuration, generate a new tower next to this one or in its place, and then go and regenerate, and this will give you a result. So this is the error messaging for the load bearing tower placing tool. The next thing is to test different configurations. I mean, here there's nothing really that difficult. You can just create multiple connected frames, and then you can place them. As I said, you can place multiple before you cancel it with exit, with escape, and then you can use this checkbox to remove some of the diagonals. So for example, you can type different number here, and if you type, let's say 1000, this is going to create 1000 millimeters, but it's not going to put the diagonal. So we can do that here and just test it quickly. T1. Oops, and this is a common mistake. I forgot to go to the other tab and press the other button. So in this way it creates supposedly the frame. Not responding. Hopefully it's not gonna die. There you go. Yeah, so this is the solution, and you can see there's spacing. This is 1000, and this is, I think, 150 or whatever I chose there. This is another case, and it's a little bit extreme. I mean, these slabs are inclined in both directions. If you look from here, and also if you look from here, you can see that they're quite extreme. In real life, you probably won't encounter a tower like this, but just for the sake of showing what we can do, I will create a few towers, and we'll see how this tool is going to handle them. So the first will be a single tower, which actually I want to create from this level, or yes, I'll create it from here because I want to align it with the section. I could have aligned the section afterwards, but anyway. So I'll just create it here, and it's not visible because I'm in the level that I don't see the whole thing from the top. So we go to the 3D view again, and this is here, and this one I created by mistake. So let's create another one with 2 and another one with 3, and let's see which one will be made and which one it won't be. So let's start, generate, and then run again. And yes, the first one was done, and the second one it has an error, which is 2 large head extensions, which means that because the tower is too high and the fixed portion of the tower is too wide, then there's not enough extension of the shoes, or the heads in this case, to cover this extension. I thought this is going to work on 2, but I guess I chose 2 extreme inclinations in both slabs, and that's why even the double tower didn't work, and the triple tower as well. In situations like this, you have to just try to fit the smallest possible tower to fit you, to work for your inclination. At the moment, we are trying to split the spacing between top and bottom evenly, so sometimes there might be a possible solution, and the system will not give it to you, but in the further versions we're going to add limitations, so we can restrain the bottom to be maximum, let's say 25 centimeters, and leave the remaining space at the top. But in this case, it should work for most cases, but in very extreme ones, you should choose a smaller tower. So this is the regular cases with the face-based families, and now I'm going to show you how to work with bridges. One more thing is to see that the system is actually following the inclined slab. So I made this section, and if you look here, you can see that the the heads are following the inclination, and as well the bases are doing the same. We're gonna have to add additional options here to encounter to take care of this situation where we have a very big inclination and we need to put some sort of a wedge, but for now it's just calculating it to the center of the base and where it crosses the slab. So yeah, and quick demo of the bridges. The bridges are, let's see in which level, I think in level 3, or where was it? There you go. So it's in level 1. So if we pretend that this is a center line of a bridge where we divide it by a certain distance, which is our influence for our section. This is basically a mass body in which I created a divided pad, and this pad I currently divided by 2.8 meters. That's it. It's just super simple spline, which in real life can be a center line of the bridge. So how we can form this quickly is we go to helpers and we switch to adaptive family. Then we create our solution, and let's say our solution is to be with 1 meter, 1 meter, and then 1 meter, and this spacing we put for something custom, let's say 3.5, and this is our family. And let's say we can make it this configuration, so we are extremely loaded, and then create family, and we hover over the line, not at the point, because at the point it makes them vertical, so you have to put it in between the points and put one here, one here, one here, and one here. Then very quickly you can align them with just a simple align tool like this from Revit, and then we are ready to form again with the same tool. Going here, select, and this is a very common mistake. If you, it's not going to happen, and nothing is going to happen, because what we're doing is we're looking from level 1, and level 1 is only seeing one of the slabs. So currently we're selecting only one of the slabs in the helper families, and if you select the family and look at it, it says could not find valid points below or above the tower, try different bottom or top slabs. So what we need to do in this case is simply to go to the 3D. In this case, you don't see the actual middle middle part of the bridge, but you can see the families, and also you don't see the top slab, the entire top slab. So this is gonna actually trigger the same error as in these ones, because it's not, it doesn't have a slab that is covering on top. So I'll just leave it like this in for the purpose of demo. Then we start the tool, we select everything, and we just run it. Hopefully this time it's not gonna take forever to generate. And we should get a result, these 4 towers, and this one should not be generated because there's a leg that doesn't have a roof or doesn't have a bottom slab. I don't know which one is which. I suppose this is the roof. Okay, there you go. So we have the result. You can rotate and you can see that the towers are generated. And again, one thing that I didn't show is this bridge section west that shows that this slab is inclined. But again, this is not too much different than the double inclined floor and roof that I showed before that. But you can see that all the towers are following the inclination of the slab. And yeah, that's pretty much it. Yeah, this is the section and also the 3D view. And again, you cannot, everything in the material list right now, it's going to be in T0 because all the towers are T0. But if we change their name before we generate them, they will be placed in the proper location. So for example, right now we're going to have a lot of material in T0 because many towers are placed in T0, and we have T1, T2, and T3 from the original demo. So yeah, one thing that we have to make sure before we generate towers is to rename the towers accordingly, the helper families accordingly. In future, we have this tower naming tool where we're gonna have some sort of automated way to rename all the families with one click rather than just naming them one by one based on their location of the drawing. Maybe like left to right, top to bottom, we place we chose their names. So that's pretty much it. If you have any questions and test it, let me know. And if you find any errors or you can suggest any improvements, just shoot me an email. Okay, thank you. Bye. And one final thing that I forgot to mention, and I am recording afterwards, is to show you that when you click on those families, besides keeping the information for what you selected in the user interface or showing in the error message here, these fields here are dynamically created, and H means heads and B means bases or feet. What you have here are the coordinates of each head and base in millimeters from the beginning of the project, from the project coordinate system. So those in later releases would be exported directly to Excel, so you can use them for tracing the towers on site. yeah, that's a little update. Thank you.